Good morning. I'm Pranava Swarupan from CSE 6th MB section, and today we're going to be talking about 2D geometric transformation. This is part of my CGV video assignment. Let's get started. So in this video we'll talk about translation, rotation, scaling, reflection, and shearing. These are all part of the 2D transformation. First we have translation. Translation is repositioning an object along a straight line path from one coordinate location to another coordinate location. As you can see in this figure, this point P of x comma y is replaced into P dash of x dash comma y dash. So first we have y-axis increase and x-axis increase. So tx is how much it is increased. So from our figure we can write that x dash is equal to x plus tx and y dash is equal to y plus tx. And here we have a square that is translated. So translate of 2 comma 4 is 2 in x-axis and 4 in y-axis. So this cube is moved 2 spaces to the right, that is x-axis, and 4 spaces to the top, that is y-axis. So it's here. And the pair tx ty is called translation vector or shift vector. The above equation can also be represented using the column vectors. And as you can see here, matrix representation P is equal to x by y, P dash is x bar by y bar. So you get T as tx by ty, and we can write the same thing as P dash is equal to P plus t. Next we have rotation. In rotation, we rotate the object at particular angle theta from its origin. From the following figure, we can see that the point P pxy is located at an angle phi from the horizontal x coordinate with distance r from the origin. As you can see, this is the original point x comma y, and this is phi. So this is located at an angle phi from the origin, that is from here. So let us suppose you want to rotate it at the angle theta. After rotating it to a new location, you will get a new point P dash, that is x dash comma y dash. So here, as you can see, the radius is constant when it's rotating, and so it rotates. That is, it adds on to theta. So the new phi would be theta plus phi, and this is the point after rotation. So we get x dash is equal to x cos theta minus y sin theta, and y dash is equal to x sin theta plus y cos theta. And the above equation can be represented in matrix form as this: x bar y bar is equal to xy into cos theta sin theta minus sin theta cos theta, that is r. This part here is the rotation matrix. So p bar is equal to p dot r, that is p into r. As you can see here, a triangle is rotated 90 degrees. This is with respect to the origin. So this point is steady here as well when this is rotated 90 degrees, and this is also rotated 90 degrees. As you can see, this is the radius. Let's say it'll take these 2 points into consideration, or any one of them, and rotate it 90 degrees from the origin. So yeah, you get this. Next we have scaling. To change the size of an object, scaling transformation is used. In the scaling process, you either expand or compress the dimensions of the object. Scaling can be achieved by multiplying the original coordinates of the object with the scaling factor to get the desired results. So scaling is basically increasing or reducing the size. So here you see A, B, C, D, and this is basically enlarged, and this is what you get. Let us assume that the original coordinates are xy. The scaling factors are sx, sy, and the produced coordinates are x bar, y bar. This can be mathematically represented as shown below. That is, x bar is equal to x dot sx, y bar is equal to y dot sy. So sx and sy are scaling factors for x-axis and y-axis. And the above equation can be represented in matrix form as shown below. This is a matrix form, and as you can see, this is a scaling matrix S, that is sx0 and 0 sy. This can also be represented as p bar is equal to p dot s, that is S scaling matrix. So here a rectangle is scaled, so scale 2 comma 3. So x-axis is scaled twice and y-axis is scaled 3 times. As you can see here, this is the y-axis, so it's increased 3 times, that is it's multiplied. So you get it somewhere here. and this is scaled twice, so x-axis is multiplied twice. So this is the end result you get. And note is, if we provide value less than 1 to the scaling factor s, then we can reduce the size of the object. If we provide the values greater than 1, then we can increase the size of an object. So yeah, scaling factor is multiplying it. So if you give the scaling factor as anything greater than 1, it will increase in size. Less than 1, it will reduce in size. And if it's 1, it will stay the same. Yeah, next we have reflection. Reflection is a mirror image of original object. In other words, we can say that it is a rotation operation with 180 degree. In reflection transformation, the size of the object does not change. The following figures show reflection with respect to x and y axes and about the origin respectively. So as you can see, yeah, this is original object 1, and 1 dash is reflection along the x-axis. So it's here, and this is around the y-axis. This is okay, 1 2 3 and 1 dash 2 dash 3 dash, and this is the original object, that is a triangle, and the reflected is this 1 dash 2 dash 3 dash, and this is along both x and y axis, and this is reflection along an axis, that is the given line. In reflection the size does not change, that is important. Okay, next we have shearing. A transformation that slants the shape of an object is called the shear transformation. There are two shear transformations, x shear and y shear. One shifts x coordinates values and the other shifts y coordinate values. However, in both the cases, only one coordinate changes its coordinates and other preserves its value. Shearing is also termed as skewing. Here there's original object, that is a rectangle, and this is shear in x direction. So as you can see, this object's shape is changed, and basically this is moved to the right, and object looks like it's pulled and stretched. This is shearing in y direction. As you can see, in y axis this part is moved upward, and shearing in both direction. This basically distorts the image and changes the shape. This slants the shape. The number of sides will still remain same. Now let's talk about x shear. X shear preserves the y coordinates and changes are made to x coordinates, which cause the vertical lines to tilt right or left as shown in the figure below. So as you can see, this square is original object, and this is x shear, that is it's tilting to the right. The transformation matrix for x shear can be represented as, so x shear is, this is a matrix of shear for x axis. So as you can see, this 1 shx, this is the shear value for x. So the y axis, the y bar becomes y plus shy into x, and x bar is same, so it's x. Next is y shear. Y shear preserves the x coordinates and changes the y coordinates, which causes the horizontal lines to transform into lines with slopes up or down, as shown in the following figure. So this is original object, and after y shear, that is it's moving upwards in the y axis. And y shear matrix is this, as you can see here. Y shear, it's 1 0 0, shy, that is shear of y 1 0, and 0 0 1, and x bar is equal to x plus shx dot y, or into y, and y bar is y. And last we have composite transformation. If a transformation of the plane T1 is followed by a second plane transformation T2, then the result itself may be represented by a single transformation T, which is a composition of T1 and T2 taken in that order. This is written as T is equal to T1 into T2. Composite transformation can be achieved by concatenation of transformation matrices to obtain a combined transformation matrix, that is X. A combined transformation matrix is T into X is equal to X into T1 into T2 into 3T, T3, and that goes on till Tn, where Ti is any combination of translation, scaling, shearing, rotation, and reflection. Okay, so now let's see this. Let me take these two as an example. This is a rectangle. So uh, yeah, first we have translation. So what I'm doing now is translation, that is moving the object. Now let's say this is the origin, so I'm moving it up. This is Y translation, moving it right. This is X translation. And here we have rotation. Now this is rotating around the center point, center of this image. So yeah, this is a rotation of 90 degrees and again 180. And now let's see reflection. Yeah, okay, wait. Yeah, here it is. Now let's select this. So yeah, if I flip horizontally, this is reflection to the x-axis. As you can see here, it's flipped. And now this is rotation. So let's rotate 90 degrees. And now I'll show you flip vertical. And this is reflection about the x-axis. And this is basically scaling. As you can see, I'm increasing the size of the image of the object rectangle. So let's say this is original scale, and as you keep increasing it, it's increasing in scale. And if this is original and you give the scaling factor as a value that is less than 1, it will reduce the size. And that is all. Thank you. Please like, share, and subscribe. Thank you once again.